The average hourly wage for manufacturing workers in the United States is $20.55 per hour, with a standard deviation of $1.17. Assuming the data is normally distributed, what is the probability that a randomly chosen manufacturing worker makes less than $21.92 an hour? So what we want to do here, this is a normal distribution, but it's not a standard normal distribution, okay? So we still have that lovely bell curve, but now the center, the mean, is 20.55 per hour. That's our mean there, 20.55, okay? We want to know the probability that a randomly chosen manufacturing worker makes less than $21.92 an hour. Okay, what is the probability that a randomly chosen manufacturing worker makes less than $21.92 per hour? So that's probability that X is smaller than $21.92. Let me make it so you could actually see that there. There we go. So what that looks like graphically, remember, probability equals area. So what we want to find is, let's see, 21.92, that's bigger than $20.55, so it's somewhere over here, 21.92. And we want the probability that we're going to be less than 21.92. So we want this area over here, okay? So our strategy for this, when we are dealing with a non-standard normal distribution, we first convert it to a standard normal distribution, okay? So let me illustrate. So we start with our X, okay? And we go to our standard normal distribution, which we usually notate with a Z. And the way we do that is with the equation X equals X minus mu over sigma. This is always how we do it. It's always the value minus the mean over the standard deviation that gives us our Z-score. Once we have our Z-score, we can find the probability, which is what we're looking for, using the p-norm function in R. Okay, so that's our strategy here. So let's go ahead and do that. So first step, we need to find that Z-score. And if we look at the problem, we can see that that's the first thing it asks for. Whoops. We can see that that's the first thing it asks for. It asks us to list the Z-scores needed to calculate the results. Okay, so to get the Z-score, we're just going to use this formula right here. Okay, our X that we're going to use in the formula is 21.92. That's the value we're interested in right here. Okay, 21.92, that's the boundary value. The mu we'll use for the formula, we were told, it's the mean, 20.55. And then the standard deviation we were also told. So if we go back up, we could see the standard deviation with a standard deviation of $1.17. And so that's our sigma. And so to calculate our Z, we're going to have our X minus mu over sigma, which in our case is going to be 21.92 for the X, minus 20.55 for the mu, over 1.17 for the sigma. Okay, so let's go ahead and throw that into our notebook to get our Z value. There it is. So, and I'm actually going to store it in Z, in the variable Z. So that was, let me pull it back up here, 2192 minus 2055. So 2192 minus 2055 divided by $1.17. I do want to point out here that these parentheses here, this one, they're very important. We want to divide this whole thing, the 2192 minus 20.55 by $1.17. If I leave out of those parentheses, if I were to leave these out, then only, the 2055 would be divided by the $1.17. I want to divide it all by the $1.17. So those parentheses are essential. Okay, let's run it. And it's not doing anything because I forgot to actually print the z. So let's just write z there. Let's print it out. And there we go. There's our z, 1.1709. So I'm just going to copy this, copy the whole thing, and I'm going to paste it. That's our first z value there. We only have the one, so we don't need to deal with any of this comma business. That's our z value, okay? So looking at this diagram here, we've done this first step. We've gone from x to z. We've gone from a general normal distribution and converted it to a standard normal distribution. Now that we have that value, we can find the probability using the p-norm function, okay? So our z value is z equals 1.1709. And now let's use our p-norm function to plug that in. And if you want to be extra careful, you could copy and paste it in, though 4 decimal places is probably fine. And we have to decide what kind of tail we want. So if we go back to our original picture, we could look to see what side of the tail we shaded in. And we could see here that we shaded in the lower tail, okay, because we want values less than 2195. So I'm going to have lower tail is true. So run that, and there it is. There is our probability. So the probability that x is less than 2192 is the same as the probability that z is less than 1.1709. That's what we found. That's what the z-score means. And we just found that that probability is 0.8792 about. Okay, so interpreting it in the context of the problem, the original problem, we're talking about the probability that a randomly chosen manufacturing worker makes less than $21.92 an hour. So there is an 87.92% chance that a randomly chosen manufacturing worker makes less than $21.92 per hour. Okay, so we have that, and now let's take this, let's put it into our notebook. Sorry, not our notebook, as the final answer here. So I've copied it, I pasted it in. Okay, click submit, and we have it.